Welcome to the CANNA Webinar. My name is Peter Klaassen. I'm Grow Consultant from CANNA. Today's topic is pH. pH is a very difficult subject. To start with, what is pH? Well, when we have 2 cups of water and we put acid in and creating a pH of 3, and in the other one we create a pH of 7, when we mix these 2 liquids together, what will be the average pH? It's not 5. Because pH is counted and in a logarithm we create a number. pH 3 is actually standing for, on the 3rd spot behind the dot, it's a 1. So 1,000th of the acid parts is in a liter of water. But pH 7 has on the 7th spot a number 1, and that means 1/10,000th of parts of acid is in a liter of water. That means if we mix them, you don't get the average number 5, but actually you get pH 3 dot and a little bit. But that will only happen in real normal water. Tap water is not 100% water. It's a mixture combined with carbonates or bicarbonates, which is a kind of pH buffer. Why? It can react with the acid in the solution. For example, if we have Coca-Cola, that is an acid solution with carbonates. As long as we keep the cap on the bottle, the pH stays quite acid, but as soon as I take the cap off, the CO2 can disappear. It can go out of the solution. Eventually, the Coca-Cola doesn't taste so nice anymore as it should. The same thing happens also in your nutrient solution. I created a pH of 6 today. I watered my plants, but the next day, if I still have some solution left over, the pH was not 6 anymore, it changed to a higher number because the carbonates from the tap water was reacting with the acid, and because you get less acid, the pH goes up. How can I solve that problem? I can solve the problem by putting a styropor layer on top of the solution. When you give water, that layer will go down with the surface of the water, so CO2 cannot escape. In that way, the pH stays more stable in your solution. Roots, on the other hand, do breathe. So when we give water to the plant, actually we give it to the substrate, and the roots are standing in that substrate. By breathing, they need energy and oxygen, of course they get it, but they produce CO2, the same as we do when we breathe. But that CO2 stays in the substrate, in the solution, so actually it's the same reaction but other way around. And that means the substrate will acidify itself. That's not the only process what is happening and will influence the pH level. What will also happen is the uptake of nutrients, because they have an electric load, will change the pH. When the roots take nutrients, then depending on the electric load of that nutrients, if it is positive loaded, the pH will go up, and if it's negative loaded, the pH will go down. It all happens in the root zone in the substrate. We can show it also in a kind of balance. When the plant is taking the nitrogen, because he is needing the nitrogen the most in vegetative phase 1 and 2, the pH will go up to a higher level. But that means that not all nutrient elements are available. In the graph, you can see, this is the graph from pH 4 till pH 9, that every element which is in the solution, they have a kind of solvability. When it is 1 centimeter high, it means the plant can take it all, 100%. But for example, if we take phosphor at a pH level of 7.5, although we gave 2 elements of phosphor and the plant needs those 2 elements, he can only take half of it, which is only 1. That means the plant will show a deficiency of phosphate. Although you give the right amount, it was not all available for the plant. And the same will happen in vegetative phase with the trace elements. Often the pH goes up in the beginning period, and because of that he cannot take all the trace elements and the phosphor out of the solution, resulting in new leaves which are a little bit light green, sometimes even yellow. Although a lot of people call it a deficiency of nitrogen, actually it's the deficiency of trace elements. After the vegetative phase, you will see it will flatten out and it goes even backwards. The reason that it goes backwards is that the balance comes from the high level back to a lower level again. And in the vegetative nutrients, for example, CANNA Vega, it also has a positive loaded nitrogen and potassium. And as soon the plant is going into the flowering phase, generative phase number 1 or 2, he needs more of these elements, so it comes back again. We always say every grower can grow between week 3 and week 5 of the flowering phase. Because the pH is okay, the plant can take all the nutrient elements which he put in the nutrient solution. As you can see, between 5.2 and 6.2, all feeding elements are available for 100%. So the plant can take them all. So between 3 and 5, all growers can grow. The balance comes back again, so we are staying somewhere between 5.2 and 6.2. All nutrient elements are available for 100%, and that is why growing in that phase is actually quite easy. But then we are heading to week 5, and as you can see, it is possible that the pH comes down, because when we start to give more of the flowering feed, and especially PK 1314, which contains potassium, then you will see that that one can bring the pH down to a very low level. It often happens in the generative phase number 3. In that way, we get on the left side of the right pH range. A pH lower than 5, none of the feeding elements are available for the roots for the plants. So actually the plant starts to suffer from it. Except one element, manganese. And often you will see slowly that the plants become green, dark green, but very dull. That means actually he should take other metals. He cannot get it, so instead of that, it will take the manganese metal. That makes the color dark and dull. But it goes on, because some of those cells will even break. If you look at the leaf, then you see next to the veins small brown spots. It's an excess of the same manganese, because that's the only element he can still get. After that process, because the plant is still willing to grow, the plant will sacrifice that leaf. The leaf is damaged, so he takes everything out because he doesn't get nutrients from the root. So the new leaves or even flowers you will not see anything about it yet, but the whole factory collapsed. So this year you're gonna get a very early autumn, because that's the color the plant gets. Don't get in that low pH level. That's the reason we have to measure. But how do we measure? In general, don't take the drain sample, because it can mislead you. Often it gives the water what you were giving. If you do it, take the second or the third drain from that substrate. Actually, it's the first drain what comes out. But in general, we take an analyze from the substrate. If you get it back, realize that the pH what you have is maybe a little bit diluted, but the number you get is the real number, because the number of a pH is a logarithm. So even when I dilute it 10 times, the number goes only up with 1. It's not always possible that you can take a soil sample. If you have enough plants, no problem, but you do damage the root zone. So if you are limited in amount of plants, at least remember that 3 moments are very important. The first week of flowering, we know the pH can become high. If the plant looks a little bit pale, consider to take a sample to confirm you have a problem with the pH. Another moment, which is week 5, that is to take the decision of pK 13-14. When the pH is still high in the substrate, you can give the full dose of pK, but maybe it's already a little bit lower, so you have to consider a half dose or maybe even no pK at all. After the pK, that is flowering week 6, then you have to consider what was the effect of pK 13-14. Is the pH already low, yes or no? Because in that case you can give a flush with pH controlled water, so the number what it should be, or that you don't control the pH of the water, so you give a high pH 7 to compensate the low pH in the substrate. So the ideal pH for the root zone is between 5.2 and 6.2. But that doesn't mean that every substrate can handle this low pH. Terra, when it is a potting mix combined with lime, then we have to remember that lime will react with acid. So if we give a low pH, lower than 5.8, I will break down the lime and my terra becomes 100% peat. And peat has a pH of 4. You cannot grow on that low pH level unless you grow in a different way, in a hydroponic way on that substrate. A lot of potting mixing are based on peat. And to avoid that low pH of the peat mix itself, what they do is they start growing in a hydroponic way. Of course, then you need an A and a B substrate, because in the A we have calcium, which we normally put in the terra mix. Another substrate, cocoa and cocoa, is still an organic product. Acid will damage organic products. So when the pH is too low, you break down the structure of your substrate. For cocoa and cocoa, we recommend a pH between 5.5 and 6.2. And of course, the low pH we give in the vegetative phase, 5.5, and when we go into flowering, we go up little by little till we reach 6.2 in flowering week 5. And for the hydroponic systems or recirculating system, you can make use of the full range from 5.2 in the beginning in vegetative phase and 6.2 the highest number, which is in the flowering week 5, 6, when we try to give the extra pK 13, 14. For organic fertilizer, it's a totally different story. Actually, the pH is not important. The plant takes what it needs. But how does the plant do it? Well, I already explained that roots do breathe. They produce CO2, but in water it means they create acid. And with that acid, they can break down the organic structure of the fertilizer. An organic fertilizer has the elements bounded to it. So it has no EC level either. But when the root gives his acid, it will break the organic structure, and the potassium is temporary a mineral, but it will absorb it and it is gone again. So actually it's the root who decides which element he wants to have. But you also have to watch out, because if you start to pH your water, then that acid from your water can break the organic fertilizer. And then, of course, that acid will break the potassium, in this case, from the organic fertilizer, which means you made a mineral fertilizer. Can you grow on it? Yes, you can still grow on it, but it's not the way how it should. And if you brought too much acid in, maybe you took too much nutrient elements from the organic structure, and then you can get an overdose even on an organic fertilizer. So in general, never control pH with organic fertilizers like CANNA. But there is one exception. If you have very hard water, that hard water contains carbonates and bicarbonates. That bicarbonate can take the acid from the roots away and neutralize it. Actually, it's making water and CO2. That's not so important, but the problem is the acid which was produced by the root to break the organic structure is now vanished. That means the plant doesn't get his potassium what he was needed. How can you solve that problem? Well, the day before you start making your nutrients solution, what you do is you add some acid to that water. So actually you bring your pH to a level of 6. You leave it for 12 hours and the next day you put in the organic fertilizer. Although the pH went up again, you don't pH it anymore. So only for hard water, it's an exception to pH the water before you add an organic fertilizer. This was the topic of pH. We can imagine that you still have some questions. Don't hesitate to contact us. We are specially for you to answer them. My name is Pieter Klaassen. Thank you for listening.